welcome to True Projects. In this video, we are going to discuss about project recommendation systems for open source communities. Introduction. The open source community consists of globally scattered contributors who share a common interest in addressing needs spanning small projects to major innovations. Platforms like GitHub serve as a vital hub for coding, sharing, and storing projects. Open source initiatives are freely started, maintained, and contributed to enhancing technology for all, including non-developers. However, pinpointing suitable projects amid the community's vastness is challenging. A solution lies in an open source recommendation system, streamlining project discovery and saving developers time by amalgamating dataset descriptions and source code comments from the project README files. The proposed system aims to deliver high-quality recommendations. The model employs the k-nearest neighbor, which is KNN algorithm for project suggestions. Coming to objective, the project's aim is to create a recommendation system tailored to the needs of contributors in the open source community. This system addresses the challenges faced by helping developers efficiently discovering pertinent projects, thus saving time and effort. By employing a recommendation-based approach, this project strives to offer personalized suggestions that match users' interests and expertise when searching for projects. The primary objective is to enhance an open source community experience by simplifying project discovery. The proposed system achieves precise and high quality recommendations by integrating both dataset descriptions and source code comments from project README files. Leveraging the k-nearest neighbor, which is KNN algorithm, further amplifies the system capability to provide relevant and individualized project suggestions to users. These are the requirements for execution. In hardware requirements, operating system of Windows, processor of i5 and above, RAM of 4 GB and above, and hard disk of 20 GB and above. In software requirements, Python IDE of 3.7 version is needed. These are the design modules and the methodology for execution of the project. First one is upload open source dataset. Using this module, we will upload dataset to application. Second one is pre-process code and comments. Using this module, we will read all comments and values and then build a training vector. In this module, we will replace all missing values with 0. Using this module, we will split dataset into train and test, where application use 80% of data size for training and 20% for testing. Third one is train KNN algorithm. K-nearest neighbor, which is KNN, is supervised machine learning technique that predicts the class or a value of a data point based on majority class or average of its interest nearest neighbors. The project employs KNN to develop an open source recommendation system. KNN's ability to find similarities between projects using dataset descriptions and source code comments enhances accurate project suggestions, improving project discovery and fostering collaboration. In this module, processed dataset will be input to KNN algorithm to train a model, and then model will be applied on new test dataset to predict source code. Repository name: 20% test data will be applied on trained model and then calculate accuracy or correct prediction. Fourth one is comparison graph. Using this module, we will plot accuracy, precision, and recall graph. Fifth module is predict open source project. Using this module, user can enter any source code related to query, and then KNN will predict GitHub repository name of that query. For execution, we need to open the code folder. This is the code folder of the project, and this is the dataset folder, and this is the source code repo file, and these are the source codes. And this is the model file, which contains NumPy file stored in it, and this will be loaded into the project code during runtime to utilize the trained models. And this is the data link file, and this is the run.bat file. Instead of executing the project in command line interface, we have created Windows batch file for execution. And this is the source recommendation file, which is Python main code file. Now we need to double click on run.bat file for execution. This is the graphical user interface of the project. With this, we will be interacting with the program, and this is created by using Tkinter library in the Python. So first, we need to click on the button Upload Open Source Dataset to upload the data. So here we are selecting source code repo data and clicking on Open. Here, it is confirmed that the data is uploaded, and here we can see few records of the data. And in this data, we have 5 rows and 258 columns. Now we need to pre-process because non-numeric data should be converted to numeric, because algorithms cannot take the non-numeric data. So now we'll click on the button pre-process code and comments. Here dataset is pre-processed. Now we have total records found in the dataset are these many, and total features found in the dataset are these many. And then the data set is split into train and test. In train we have 13,229 records. In test we have 3,308 records. Data set of 80% is train and 20% is test. Any algorithm, initially they will be trained on train data and then they will be predicted on test data. Now we'll click on the button Train KNN Algorithm. Here we got the KNN confusion matrix. Here on x-axis we have predicted class, on y-axis we have true class, and these two are the true classifications, these two are the misclassifications. And here we got the accuracy, precision, recall, f-score of KNN algorithm. Now we will be clicking on the button comparison graph. Here on x-axis we have types of metrics and on y-axis we have score of that particular metric. This is the accuracy, this is precision, this is recall, and this is f-score. Now we'll close this graph. Now we need to enter a project topic in text field to predict open source project. So here I will enter. So this is the project topic. Now I will be clicking on the button Predict Open Source Project. So here we got some recommended open source project for the given query. And these are the source codes. And this is the matching similarity. Now we'll select this comment, which is source code. We will copy it in the GitHub. Now we'll search it. Here we got the recommended projects. Similarly, we can copy any comment which is source code and then type it in the GitHub or any other repository for getting the recommendation systems. Now we'll close this. And now exit the GUI. Conclusion. The project pioneers an innovative solution for open source project recommendation by harnessing source code and dataset comments. The system improves search accuracy by using the k-nearest neighbor, which is KNN algorithm, solving the shortcomings of current approaches. The project uses dataset from a GitHub repository and achieves outstanding accuracy during data pre-processing, KNN training, and testing stages. The simple modules make it easy to upload datasets to pre-processing and view the results. The project speeds up project discovery and emphasizes the value of taking code and comments into account by improving search accuracy. The system gives programmers the ability to quickly find and use reusable modules, which promote efficient teamwork and software development.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.